There is a question concerned with the normal distribution for AS level, for A2 levels for statistics. The question statement is in Jaipur, the weight in kilograms of boys aged 16 years have a normal distribution with a mean 61.4 and standard deviation as 12.3. Part 1. Find the probability that a randomly chosen boy aged 16 year age in this Jaipuri weights is more than 65 kg. So this is a topic concerned with the normal distribution. We know that the normal distribution has mean mu and standard deviation as sigma there. So mean there is given there equal to 61.4 and standard deviation given there is 21.3. And you are going to find out in the first part, student selected from that portion is having a mass more than 65 kg. So we will convert it to that. We know that Z is basically equal to x minus mu over sigma. Change it in the standard form of that number distribution. So probability of Z is greater than x, which is 61.4, is 65. Well, this is x value there. Then mean is 61.4 over standard deviation is 21.3. This probability will be equal to Z is greater than 65 minus 61.4 over 21.3 is basically equal to 0.2927. So this is the normal solution for that. Since this is positive 0.2927 and this is the region which is going to be calculated there. So it should be equal to probability of Z more than 0.2927 is equal to 1 minus phi of 0.2927. And this will be equal to 1 minus, from the table, you can calculate that value there. And that value is equal to 0.653. And that value is finally calculated equal to this value is equal to 0.385. The next part, for the age 16 years in Jaipuri, 25% have the weight between 65 kg and kilograms, where k is greater than 65. Find the value of k there. So for the second part, we are asking find the probability of x more than 65 kg less than a is equal to 25%, which means probability of 65 less than x less than k is equal to 0.25. Now, we know we have this is the general form of this normal distribution, and now we have to convert it to the standard form. So, probability of P that is equal to 65 minus 61.4 over 21.3 is less than Z is less than K value. So that is K minus 61.4 over 21.3, and that is equal to 0.25. And this value we have already calculated it there. That is equal to 0.2927 is less than Z is less than K minus 61.4 over 21.3. That is equal to 0.25. But if we suppose, let's say value of A is equal to A minus 61.4 over 21.3, then this will become probability of Z greater than 0.2927 is less than A there, and that is equal to 0.25. If we draw this on the Venn diagram, then this is the value of this initial value, that is 0.2927, less than this value is equal to A, and this portion is going to be calculated for this probability there. So we can write this in the form of the general function. So phi of A minus phi of 0.2927 is equal to 0.25. So phi of A is equal to phi of 0.2927 plus 0.25, and phi of 0.2927 is basically calculated there equal to 0.6153. 0.6153 plus 0.25. So that value is equal to 0.8653. Then A value, phi of A is equal to 0.8653. Then A value is equal to phi inverse of 0.8653, and that value is equal to 1.105. But we know that A is equal to K minus 61.3, 61.4 or 21.3 is equal to 1.105. 105. K minus 61.4 is equal to 1.105 into 21.3. Our K value is equal to 75. So this is the part 2 of that question statement given. Now we will have to see the third statement of that question. In Brick Valley, the weights in kilograms of the aged 16 years have a normal distribution. 99% of the boys have a weight less than 97.2 kg and 33% of the boys have a weight less than 55.2 kg. Find the mean and standard deviation of this weight of this aged 16 years old in the village. So this is probability of Z is equal to this, where let 99.2 minus mu over sigma is equal to A, where probability of Z less than A is 0.99. You draw this figure. This is the value of A. So phi of A is equal to 0.99. A is equal to phi inverse of 0.99. And that value will be calculated as the second information there is, so phi is equal to 2.23. So we can write this thing as A is equal to 99.2 minus mu over sigma is equal to 2.326. Let's say it is equation number 1. Now we use the second information here, that the probability of x less than 55.2 is equal to 33%. So this means probability of z is less than 55.2 minus mu over sigma is equal to 0.33. Let 55.2 minus mu over sigma is equal to p value there. Then probability of z less than p value is equal to 0.33. So this is the value of minus b because it is on the left side of that mu there, which is considered as 0 over there. So we can write this thing as 1 minus phi of minus b is equal to 0.33, or phi of minus b is equal to 1 minus 0.33, which is equal to 0.67, or minus b is equal to 5 inverse of 0.67. And if we look at the calculator for the standard table of this deviation, then the value of this is equal to 0.44, or b value is equal to minus 0.44. Now we use these two informations for b value is basically equal to D there is equal to 55.2 minus mu over sigma is equal to minus 0.44. That's it. That is equation number 2. Now we can solve 1 and 2 simultaneously. Then 55.2 minus mu is equal to minus 1.44 into sigma there. And the second information there is 99.2 minus mu is equal to 2.326 sigma. That's it, that is 1, that is 2. Now we can solve these two equations simultaneously. When the mu value will be calculated is equal to 55.2 minus 99.2 is equal to minus 0.44 sigma minus 2.326 sigma there. So the value of mu there is equal to 61.98. And keeping the same values for this sigma there, that is equal to using 1 or 2, any one of that equation we can use, and value of sigma there is equal to 15.2 there. So these are the values of mean and the standard deviation of this when the information there is that x value is less than 99.2 is 0.99% and probability of x less than 55.2 is 33%. So this is the complete solution of this problem there.